Hello everyone, this is Miss Lindsay. Today we're going to talk about section 3.2 and 7.2, proving triangles congruent. First, let's talk about what is meant by included in a triangle. So if I'm referring to angle G is formed by sides GE and GO. So in other words, angle G is between those two sides. So what we would say is angle G is included by sides GO and GE. So again, I'm referring to angle G. It is made up by sides GE and GO, so it is included between those two sides. Oops. Let me go ahead and rewrite those two sides. So if I'm referring to angle E is included by sides EO and EG. We can also do the same idea if we're referring to sides. If I'm referring to side GE, so if I'm referring to that side GE, is in between or included by angle E and angle G. So again, side GE, it's in between, or in other words, included by the two angles E and angle G. So if I'm referring to side GO, is included by what two angles? Go ahead and fill that in. What two angles would side GO be included by? And if you said angle G and angle O, you would be correct. Using this idea, we now can go on to the four postulates that prove triangles, two sets of triangles, congruent. You must show three congruent statements in a proof in order to show that triangles will be congruent. So our first one, if you had to guess, SSS stands for side, side, side. We have to show three pairs of corresponding sides are congruent. So if I have a triangle ABC and XYZ, I must show three sides. AB would be congruent to XY. BC would be congruent to YZ. It's my second pair of congruent sides. And my third pair of congruent sides would be to show that AC is congruent to XZ. So again, I must show 1, 2, 3 congruent statements. And in our case, the first postulate would be side, 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 showing three pairs of corresponding sides are congruent. Our second postulate, SAS, is side, angle, side. So again, I have a triangle ABC, XYZ. I have to show three congruent statements. So if I show that the corresponding sides AB is congruent to XY. Now remember, our included angle here would either be angle A or angle B. Let's go ahead and refer to angle B. Therefore, its corresponding angle would be angle Y. Well, then the only corresponding sides to angle B would be AB, which we already have, and then the other one would be BC. Therefore, side BC must be congruent to side YZ. So we must show three congruent statements in order to prove by side, angle, side. And angle B is the included angle. So in other words, it's in between the sides AB and BC, as well as Y is the included angle, which is between side XY and YZ. It's in between those. The other two postulates are angle, side angle. Again, let me go ahead and mark my triangles with ABC and XYZ. I must show three congruent statements on this one. So again, angle A would be congruent to angle X. These are your corresponding angles. A side could be AC congruent to XZ. Now this side must be included between the two angles. So side AC's got to be included between the angles A, and then the other one would be angle C. Therefore angle C would be congruent to angle Z. That would be your third congruent statement. A direct result of angle side angle is the postulate angle angle side. There is a theorem called no choice theorem. This theorem states if you have two pairs of angles, corresponding angles congruent to two pairs of corresponding angles in another triangle, the third angles must be congruent. By this theorem, we can also prove that triangles are congruent by angle angle side. We will discuss this theorem in more detail in class the next day, but again, this is directly related from angle side angle. Using the no choice theorem, we now can also use the postulate angle angle side to show that a pair of triangles are congruent. So let me label my triangle ABC XYZ, and this one, if we have angle A, is congruent to angle X. Now this one is slightly different than our previous ones because we do not really have an included angle or side, but it does need to go in order. So if I have angle A and then I know angle C is congruent to angle Z, then the side, again, I'm going in order. I'm going around the triangle in this counterclockwise fashion. So I have angle, angle, and then I need side. Angle, angle, side. So it would be BC is congruent to YZ. And again, we will touch on angle, angle, side and no choice theorem a little bit more in class. Moving on to our examples here, let's read the directions. Tell whether the triangles are congruent by side, 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 angle, side angle, or angle, angle, side. If they are not congruent, write no. Let's go ahead and do the first one together. Again, you can see that we have three corresponding congruent sides. So this one would be congruent by side, side, side. At this time, if you would go ahead and please finish 2 through 8, marking whether or not they're congruent, and if they are not congruent, writing no. Please push pause. When you're done, then go ahead and push play to check your answers. Here are the answers for 2, 3, and 4. Please notice on 3 we have angle, angle, side, angle, angle, side. And 5 through 8, the only one of these that is no is 7. We cannot prove triangles by angle, angle, angle. We do not have a postulate for that. Just think about if we go to quadrilaterals, a square and a rectangle, those all have 4 angles that are 90 degrees, but they are not congruent. The sides would not be congruent. It's the same sort of relationship with triangles. Let's go ahead and move on to our first proof. We have our given statement. We have that AB is congruent to AD. We also know that C is the midpoint of BD. So let's go ahead and mark that. As you can see, we are trying to prove that we have 2 triangles congruent. We must have 3 congruent statements. From our markings on our diagram, we can see that we already have 2 sides. Now we might have to fill in our proof a little bit, but think about our 4 postulates that we can use. Clearly, we're not going to use angle, angle, side, and angle, side, angle because we already have two sides. So it's either going to be side, 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 or side, angle, side. So let's go ahead and fill in the proof for our two-column proof here with our first given. Then we have C as the midpoint. Therefore, we can mark that BC is congruent to CD if a point is a midpoint of a segment, then it divides it into two congruent segments. Now we're looking for either another angle or a side. Well, we do not know any more given information. The only thing that we can do is knowing that AC is shared by both triangles. Therefore, AC is congruent to itself by reflexive property. And here are our three congruent sides, side, side, side. So we can prove triangle ABC is congruent to triangle ADC by side, 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 and then listing the three steps of those congruent statements, 1, 3, and 4. Moving on to our next example, we have AC is perpendicular to BD. I'm going to go ahead and label those angles as 1 and 2, and they would be right angles. Therefore, we'd have angle 1 and angle 2 are right angles if two segments are perpendicular, then they form right angles. Therefore, we can say that they are congruent if two angles are right angles, then they are congruent. We have our next given, BC is congruent to CD. So again, we have side, 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 angle, side, angle, side, angle, 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 side. We clearly have from our givens, we have a side and an angle. We can cross off side, side, side. So we can either go angle, side, angle, but there's no way we can get angle B congruent to angle D. So that one is out of the picture. It looks like it's leaning more towards side, angle, side because we have, again, AC is shared between both triangles by the reflexive property, giving us our three congruent statements. We have an angle, we have a side, and we have another side. Therefore, triangle ABC is congruent to triangle ADC by side, angle, side. Steps would be side is BC, number 4, 3, and 5. Looking at our next proof, number 3, go ahead, pause, fill in the statements. Once you're done, push play to check your answers. So we have our given statements where we can mark the midpoints. So we have, excuse me, our markings are on there. So again, we can actually already cross off angle, side, angle, and angle, angle, side. As you can see, we can then get vertical angles. So we can get 1 and 2 to be congruent. So we are proving this by side, angle, side. The next portion that we need to actually prove is figure out what our triangle would be. So we have to match up the corresponding sides, which would be triangle ZXY. And again, one last thing, please make sure when you have side, angle, side, 2 has to be a side. The middle 6 must be the angle. And this concludes section 3.2 and 7.2. Please finish the next proof for tomorrow. Thank you.